One. Good day, everyone. I am Daniel Marco Elata.
I am Vince Joseph Inocencio.
And I'm Vincent JP Bulaong.
We'll discuss and explain everything that you want and need to know about primary and backup protection. Along the discussion, we will tackle its definition, working principle, concepts, system requirements, types, and the system protection's advantages and disadvantages. But first, here is Vince Joseph as he will test our prior knowledge about the topic.
Thank you, Daniel Marco, for very welcoming introduction. Good day, everyone. Like what Daniel Marco said, we must first have a pretest to test your initial knowledge about the power system protection and specifically in our today's topic, the primary versus backup protection. This pretest is only 5 items multiple choice, and I will repeat the question twice. After that, you must choose one answer for every question. Good luck, and let's start our pretest. For question number 1, it is the essential protection provided for protecting an equivalent or machine or a part of power system. Let me repeat. It is the essential protection provided for protecting or machine or a part of the power system. For letter A, ground fault circuit interrupter. For letter B, circuit breaker. For letter C, primary and backup protection. And for letter D, fuse. And the timer starts now. 5, 4, 3, 2, and 1. Time's up. For question number 2, it is the first line protection which provides quick acting and selective clearing of a fault within the boundary of the circuit section or element it protects. Let me repeat. It is the first line protection which provides quick acting and selective clearing of a fault within the boundary of the circuit section or element it protects. For letter A, first ground fault circuit interrupter. For letter B, primary protection. For letter C, secondary ground fault circuit interrupter. For letter D, backup protection. The timer starts now. 5, 4, 3, 2, and 1. Time's up. For question number 3, it provides the backup to the main protection whenever it fails in operation or it's cut out for repairs. Let me repeat. It provides the backup to the main protection whenever it fails in operation or it cut out for repairs. For letter A, first ground fault circuit interrupter. For letter B, primary protection. For letter C, secondary ground fault circuit interrupter. For letter D, backup protection. The timer starts now. 5, 4, 3, 2, and 1. Time's up. For question number 4, it was the circuit breaker used by both main and backup protection, but protective systems are different. Separate trip coils may be provided for the same breaker. Let me repeat. It was the circuit breaker used by both main and backup protection, but protective systems are different. Separate trip coils may be provided for the same breaker. For letter A, relay backup. For letter B, breaker backup. For letter C, remote backup. And for letter D, centrally coordinated backup. The timer starts now. 5, 4, 3, 2, and 1. Time's up. For the last and fifth question, these features aim at maintaining the continuity of supply system by disconnecting the minimum section of the network necessary to isolate the fault. Let me repeat. This feature aims at maintaining the continuity of supply system by disconnecting the minimum section or the network of the network necessary to isolate the fault. For letter A, reliability. For letter B, speed. For letter C, selectivity. And for letter D, sensitivity. The timer starts now. 5, 4, 3, 2, and 1. Time's up. And for the answers, for question number 1, the answer is C, primary and backup protection. For question number 2, the answer is B, primary protection. For question number 3, the answer is D, backup protection. For question number 4, the answer is A, relay backup. And for the last question, the answer is C, selectivity. Thank you for your cooperation. This is not graded, and the only intention of this pretest is to test your initial knowledge. And for the learning objectives, let's have Vince Nunki. Hello, Vince.
Thank you, Vince Joseph, for the wonderful introduction. For the learning objectives of this lesson, I will discuss what are the things you should know and learn after we discuss the lesson. Upon the completion of this topic, the students will be able to, first, understand the importance of protection system. Second, identify the function of primary and backup protection in power system. Third, distinguish the difference between primary and backup protection. Fourth, classify the different concepts, types, and application of protection system. Fifth, identify the advantages and disadvantages of primary and backup protection. For the first topic of this lesson will be discussed by the great Daniel Marco.
Thank you, Vince Nungi, for the wonderful introduction. Before we continue to the topic, let's ask ourselves if we really know the system protection's importance. I will help you to understand the need for power system protection. Why do we need power system protection? It is safe to claim that a contemporary electrical system would be impossible to run without discriminatory protection. The protection is required to remove any element of the power system that has developed a problem as quickly as possible. As long as the fault stays connected, the entire system may be threatened by the fault's three main effects. First, it is likely to cause the individual generators in a power station or groups of generation in different stations to lose synchronism and fall out of step with a consequent splitting of the system. Second, risk of damage to the affected plant. And third, risk of damage to the healthy plant. Next. On the picture, we see a simplified diagram of the electric power distribution. A typical electric power system network consists of generation, transmission, and distribution. Next. On the moving picture, we see a diagram that cuts the current flow when the two poles is not in contact with each other. We can relate this illustration to the basic principles of a power system protection. The concept will be significant as the report progresses. There is another effect, not necessarily dangerous to the system, but important from the consumer's viewpoint, namely a risk of synchronous motors in large industrial premises falling out of step and tripping out, with the serious consequences that entails the loss of production and interruption of vital processes. It is the function of the protective equipment in association with the circuit breakers to avert these effects. This is wholly true of large HV networks or transmission systems. In the lower voltage distribution systems, the primary function of protection is to maintain continuity of supply. Next. Obviously, this aim cannot be achieved by the protection alone. In addition, the power system and the distribution networks must be so designed that there are duplicate or multiple outlets from power sources to load centers. Adequate generation may be taken for granted, and at least two sources of supply or feeders to each distributing station. There are certain conventional ways of ensuring alternative supplies as well shall see, but if full advantage is to be taken of their provision, the protection must be must be highly selective in its functioning. Next. For this, it must possess the quality known as discrimination, by virtue of which it is able to select and to disconnect only the faulty element in the power system, leaving all others in normal operation so far as that may be possible. With a few exceptions, the detection and tripping of a faulty circuit is very simple matter. The art and skill lie in selecting the faulty one, bearing in mind that many circuits, generators, transformers, feeders are usually affected, and in much the same way by a given fault. This accounts for the multiplicity of relay types and systems in use. Definition. Next. What is primary and backup protection? Primary protection. The main protection or primary protection is the first line of defense and is responsible to protect all the power system elements from all the types of faults. The backup protection comes into play only when the primary protection falls. The main protection or primary protection provides quick acting and selective clearing of a fault within the boundary of the circuit section or element it protects. Almost 90% of faults are cleared by primary protection. The primary protection scheme ensures fast and selective clearing of any circuit fault within the boundaries of the circuit element that the zone is required to protect. Primary protection, as a rule, is provided for each section of an electrical installation. Next. Backup protection. The backup protection provides the backup to the main protection whenever it fails in operation or it's cut out for repairs. The backup protection is essential for the proper working of the electrical system. The backup protection may be provided either on the same circuit breaker, which would be normally opened by the main protection, or in the different circuit breaker. The backup protection is mainly used where the main protection of the adjacent circuit is unable to back up the main. Also, the remaining 10% is cleared with the help of backup protection. Next. This is the main concept of the protection relays on stations. The relay E and F are the first protection relays before the electricity flow in respected stations. C, D, G, and H are the ones that is enclosed in green rectangle is the primary protection. It is also known as the first line of defense. And the A, B, I, and J are the ones that is enclosed in orange rectangle is the backup protection. This is the relays that clears the remaining 10% of the fault. Next. That's all about the discussion about the definition and fundamentals of primary and backup protection. The next topic will be discussed by the handsome Beanstone KP Bulaong.
Thank you, Marco, for the meaningful discussion. And for the next topic, I will report about how primary and backup protection works. In this topic, I will tackle about the working principle of both primary and backup protection system, and also the type and methods of a backup protection. Next. So in this image, the primary protection is the relay C, D, G, and H, while the backup protection is the relays A, B, I, and J. When the primary protection fails to protect the main system, the backup protection will operate, but at the same time, the larger part of the system is disconnected due to its shutting down the area where the fault is present. For example, when the primary protection C and D fails to stop the fault, the backup protection A and B will start to operate, but at the same time, it will disconnect the rest of the system behind relay A and B. Next. In the second image, this is a visual representation of how primary and backup protection works. The fault coming from the distribution system to the service line on its way to the circuit breaker of our homes. The main circuit breakers act as a primary protection, where all the transmission lines are connected to the main parts of our homes, while the branch circuit breakers act as the backup protection where you can cut or trip a specific part where the fault occurred. In simpler terms, primary protection is similar to a main circuit breaker that is linked to a branch circuit breaker representing the backup protection. Next is the working principle of a backup protection. Backup protection works with two different ways. The first one is the time grading principle, and the second one is the backup protection by duplication. Backup protection can be classified as either local or remote. Local backup protection is provided by protection that detects an unresolved primary system failure at its own location and trip its own circuit breakers, such as time-graded overcurrent relays. This principle is to grade the operating times of the relay in such a way that the relay closest to the fault spot operate first. And if the first protection failed, there is a time lapse between the first and the second protection in order for it to activate. If the fault didn't stop within the time lapse, the next protection will operate. Next, protection system in successive zones are designed to operate at graded intervals along the sequence of equipment, such that when a fault occurs, a number of protection systems respond, but only those relevant to the defective zone complete the tripping function. The others make incomplete operation and then reset. The speed of response will often depend on the severity of the fault and will generally be slower than for a unit system. Just like in the previous discussion, the tripping time at this location are graded in such way that the circuit breaker nearest the faulty part operates first, giving primary protection. The circuit breaker at the previous station operates only as a backup. We are going to show example on how time-graded protection works. Here in this image, the fault occurs near the relay C, making the relay C its primary protection. But if the relay C failed to stop the fault, relay B will start to operate as it is the one who is near relay C. Relay B will provide protection after a time delay of 350 milliseconds. And if the worst case scenario happens, making relay C and B fail to stop the fault, relay A will operate after relay B failed. Next. And this is the explanation in this image here. Next. Next example is more complex circuit than example 1, but with the same concept. If a trip or fault happen in transmission line of relay C, for example here, all the other components in relay C will shut down due to the fact that relay C isolates its component to the fault. If relay C didn't resolve or isolate the fault, relay B will operate, and the same with relay C. It will also shut down all of its components up to relay A. Before relay B and A works, there is a time lag in order to both relay works and shut down at the same time. Next. And this is the explanation on what I said earlier. Next. The disadvantage of time grading backup protection is that it requires a vast isolated region, and if a specific transmission line experiences a malfunction, it will isolate or trip the surrounding circuit breaker. Following that, the period of breaking increases near the generator, while the short circuit current increases. The use of backup protection is determined by economic and technological factors. Backup protection is typically slower than primary protection for budgetary reasons. The next principle or ways on how backup protection works is by duplication. Duplication principle. Important protective devices such as relays, circuit breakers, auxiliaries are duplicated. Both primary and backup protections are provided at the same station and are arranged to operate at the same speed as fast as possible. Such protection is costly and the cost is justified for protection of extra high voltage transmission lines, bus bars, large generator, large transformers, and etc. As simple as it is, the word duplications explains it all. Duplicating relays, circuit breakers, auxiliaries in the system in order to protect the system. If the main protection failed, the duplicated protection will operate. But again, this principle is costly. After the working principle is the types or methods of backup protection. The first type is the relay backup. Same circuit breaker is used by both main and backup protection, but protective systems are different. Separate trip calls may be provided for the same breaker. Single relay consists of primary and backup protection. This is the most common type of backup protection. The backup relaying schemes provide this extra reliability to the system. Backup relays are extra relaying schemes attached to the equipment or part of the network with their own relaying system. The main function of backup relay is to operate in any failure or tripping of circuit breaker due to main relays, mechanical defect of moving parts of the main relay, failure of DC power supply to the relay, failure of tripping pulse to the breaker from relay, failure of current or voltage to the relay from CT or PT circuits. The second type of a backup protection is the breaker backup. Different breakers are provided for main and backup protection. Both the breakers are being in the same station. Breaker backup protection is play important role in the power system protection. Protection relay is responsible to detect the fault of transmission line or other element and isolate the part by opening the connected circuit breakers. Both primary and backup protection can be found on the same station. It is used as backup protection of the circuit to isolate the fault in case of the circuit breaker failed to trip. If any trip relay operates, it will send the trip command to the circuit breaker and also send the command as breaker backup initiation to the breaker backup relay to activate. After getting the initiation from the trip relay, the breaker backup relay is waiting for isolation of the fault. After a certain duration, if the fault current is persisting, breaker backup relay will operate and it will send the trip command to all connecting circuit breakers to isolate the fault. The next type of backup protection is the remote backup. In this method, separate breakers are provided for primary and backup protection. The two types of breakers are at the different station and are completely isolated and independent of each other. This is the opposite of a breaker backup, where its primary and backup protection are on different stations, which means they are independent on each other. If a trip or fault occurs at the primary, it can work on its own to solve where the problem starts. Same with its backup protection. Next. Last is the centrally coordinated backup protection. The system having central control can be provided with centrally controlled backup. Central control continuously supervises the load flow and frequency in the system. The information about load flow and frequency are assessed continuously. Here, system is having central control and it can be provided with centrally controlled backup. The central coordinating station receives information about the abnormal conditions through high-frequency carrier signals. The stored program in digital computer determines the correct switching operation as regards severity of faults, system stability, and etc. The main protection at various stations and backup protection for all stations is at Central Control Center. The centrally coordinated backup has its primary at its various station and backup is at control room with the help of a computer. The stored program in the digital computer determines the correct switching operation as regards severity of fault and system stability. And that's all the topic about the working principle and types of backup protection. The next topic will be presented again by Daniel Marco.
Thank you for the insightful report, Vince Nunki. For the next topic, I will discuss about the zones of protection system and its primary system requirements. The zones of protection. An electric power system is divided into several zones of protection. Each zone protection contains one or more components of a power system in addition to two circuit breakers. The circuit breakers are inserted between the component of the zone and the rest of the power system. Thus, the location of the circuit breaker helps to define the boundaries of the zone of protection. When a fault occurs within the boundary of a particular zone, then the protection system responsible for the protection of the zone acts to isolate by tripping the circuit breakers, every equipment within that zone from the rest of the system. Different neighboring zones of protection are made to overlap each other, which ensure that no part of the power system remains without protection. For the failures within the region where two adjacent protective zones are overlapped, more circuit breakers get tripped than the minimum necessary to disconnect the faulty element. Next, why protection zones overlap? The overlapping of protection, I, sorry. The overlapping of protective zones is done to ensure the complete safety of each and every element of the system. The zone which is unprotected is called a dead spot. The zones are overlapped and hence there is no chance of existence of a dead spot in a system. If there are no overlaps, then a dead spot may exist, which means the circuit breakers lying within the zone may not trip even though the fault occurs. This may cause damage to a healthy system. It can be seen from the figure that the circuit breakers here are the rectangle ones, are located in the connections to each power system element. This provision makes it possible to disconnect only the faulty element from the system. Next, protection system requirements and basic terminologies. Number one is the reliability. It is the ability of the protection system to operate correctly. The reliability feature has two basic elements, which are dependability and security. The dependability feature demands the certainty of a correct operation of the design system on occurrence of any fault. Similarly, the security feature can be defined as the ability of the design system to avoid incorrect operation during faults. A comprehensive statistical method-based reliability study is required before the protection system may be commissioned. There are two factors which affect this feature of any protection system depends on depends on some of the following few factors. A. Quality of component used. B. Maintenance schedule. C. The supply and availability of spare parts and stocks. And D. The design principle. Number 2. Speed. Minimum operating time to clear a fault in order to avoid damage to equipment. The speed of the protection system consists primarily of two time intervals of interest. A. The relay time. This is the time between the instant of occurrence of the fault to the instant at which the relay contacts open. B. The breaker time. This is the time between the instant of closing of relay contacts to the instant of final arc extinction inside the medium and removal of the fault. Next. Number 3. Selectivity. This feature aims at maintaining the continuity of supply system by disconnecting the minimum section of the network necessary to isolate the fault. Two examples of utilization of this feature in a relaying scheme. A. Time-graded systems and B. Unit systems. The property of selective tripping is also known as discrimination. This is the reason for which the entire system is divided into several protective zones so that minimum portion of network is isolated with accuracy. There are actually two examples that I've mentioned before. For sensitivity, the sensitivity of a relay to the smallest value of the actuating quantity at which the relay operates detecting any abnormal condition. In case of an overcurrent relay, mathematically, this can be defined as the ratio between the short circuit fault current and the relay operating current. The value I0 should not be too small or large so that the relay is either too sensitive or slow in responding. Next, 5. Stability. It is the quality of any protection system to remain stable within a set of defined operating scenarios and procedures. For example, the bias differential scheme of differential protection is more stable towards switching transients compared to the more simple and basic Merz price scheme in differential protection. Next. And lastly, number 6, adequacy. It is economically unviable to have 100% protection of the entire system in concern. Therefore, the cost of the designed protection system varies with the criticality and importance of the protected zone. The protection system for more critical portions is generally costly, as all the features of a good protection system is maximized here. But a small motor can be protected by a simple thermally operated relay, which is simple and cheap. Therefore, the cost of the protection system should be adequate in its cost. Next, that's all about the zones of protection and its primary system requirements. The last topic will be discussed by the hardworking Vince Joseph and Inocencio.
Thank you again, Daniel Marco, for a meaningful report and for sharing the other concepts for primary and backup protection. For the last topic, I'm gonna discuss to you the advantages and disadvantages of backup protection. The first advantage of backup protection, it is fast operation and almost simultaneous fault clearing. It has the advantage of fast operation because many of research prove that it can cut off the current in a couple of seconds once it detects that the primary protection failed. So the damage caused by fault will not go to other components. It also simultaneous fault clearing because it can handle the operation and fault clearing detection at the same time. The second advantage is it has complete reliability. It has the advantage of reliability because like what I've said earlier, it can cut off the supply in just a glimpse of a second, making it reliable to use in power industry. For the third advantage, it has a safety of persons and security of other connected components. For this explanation, the safety is in the side of operators, and the security is in the side of components. When the fault cut off by the backup protection, the operators will be safe from possible electrocution, and the security of the components will be secured because the part that was affected are the only one who will stop and possible subjected to replacement, but the other will retain because it was not affected by the fault because it was first cut off before reaching the other components. The fourth advantage is it has safety and security of distribution for continuous operation. For this advantage, it was related to number 3 advantage, simply because if only one of the components are affected, the other sides and the other components will continue to operate for supplying the demand of the consumers. The only thing will happen is that the load of the one component that was affected will be shouldered by the other components until the affected components will back to its operation. That will give us safety and security for continuous supply and operation. And the last advantage is It has economic stability. We have a lot of advantages in using backup protection, but let me end this for the most important advantage, which is economic stability. All the advantages are linked to this advantage because if the power system operation will stop, the effect will be like capillary effect, and the operations of the user will also stop and ends in economic losses. But because of this backup protection, the operation stoppage will be lessened to least possibility, and it will continuously operate even the other components have a problem. And as a contrast in the advantages that we mentioned, let's go to the disadvantages of backup protection. In researching the disadvantages of backup protection, the only one I've seen disadvantage is that the backup protection is costly. It was costly in one simple reason. Because before having a backup protection, you need to buy another set of system protection, and the system protection is expensive, like what Daniel Marco said and Vince Nunki earlier. If you will buy two system protection, the primary and secondary, it will be very expensive. But the most important aside from its cost is that the safety that will give by a protection system to the operation. And that's the most important. Before ending this lesson, let's have a graded evaluation in the form of post-test to test your learnings in the discussed topic. And in the end of this post-test, you will know your performance rating in understanding this lesson based on what score you will have. So let's start our post-test. For the question number 1, it was the circuit breaker used by both main and backup protection, but protective systems are different. Separate trip coils may be provided for the same breaker. Let me repeat. It was the circuit breaker used by both main and backup protection, but protective systems are different. Separate trip coils may be provided for the same breaker. For A, relay backup. For B, breaker backup. For C, remote backup. And for D, centrally coordinated backup. The timer starts now. 5, 4, 3, 2, and 1. Time's up. For question number 2, it is the first line protection which provides quick acting and selective clearing of a fault within the boundary of the circuit section or element it protects. Let me repeat. It is the first line protection which provides quick acting and selective clearing of a fault within the boundary of the circuit section or element it protects. For A, first ground fault circuit interrupter. For B, primary protection. For C, secondary ground fault circuit interrupter. And for letter D, backup protection. The timer starts now. 5, 4, 3, 2, and 1. Time's up. For question number 3, it is the essential protection provided for protecting an equivalent or machine or a part of a power system. It is the essential protection provided for protecting an equivalent or machine or a part of the power system. For A, ground fault circuit interrupter. For B, circuit breaker. For C, primary and backup protection. And for letter D, fuse. The timer starts now. 5, 4, 3, 2, and 1. Time's up. For question number 4, this feature aims at maintaining the continuity of supply system by disconnecting the minimum section of the network necessary to isolate the fault. This feature aims at maintaining the continuity of supply system by disconnecting the minimum section of the network necessary to isolate the fault. For letter A, reliability. For letter B, speed. For letter C, selectivity. And for letter D, sensitivity. The timer starts now. 5, 4, 3, 2, and 1. Time's up. For the last and fifth question, it provides the backup to the main protection whenever it fails in operation or it cuts out for repairs. It provides the backup to the main protection whenever it fails in operation or it cuts out for repairs. For letter A, first ground fault circuit interrupter. For letter B, primary protection. For letter C, secondary ground fault circuit interrupter. For letter D, backup protection. 5, 4, 3, 2, 1, time's up. And for the answers, for number 1, it is A, relay backup. For number 2, it was B, primary protection. For question number 3, it was C, primary and backup protection. For number 4, it was C, selectivity. And for the last question, the question number 5, it was D, backup protection. For your performance rating, for the students who got 5/5, you are outstanding. And for the student who get 4/5, you're very satisfactory. And for the student who got 3/5, you're satisfactory. And for the student who get 2/5, unsatisfactory. And 1 or 0/5, it was poor. And then the student needs to relearn the topic and study hard. So I hope that all of the students got a high score. So before ending this lesson, let's have Vince Nunki for the key points.
And for the key points or main points to be remembered from this topic. Next. First is the primary protection is the main line of defense and is responsible of protecting all power system elements from all type of faults. Next is the backup protection comes into play only when the primary protection fails. Next is the backup protection provides the backup to the main protection whenever it fails in operation or it's cut out for repairs. The ability of protection system to operate correctly is called reliability. Minimum operating time to clear a fault in order to avoid damage to equipment is called speed. Selectivity features aims at maintaining the continuity of supply system by disconnecting the minimum section of the network necessary to isolate the fault. The sensitivity of a relay refers to the smallest value of the actuating quantity at which the relay operates, detecting any abnormal condition. Stability is the quality of any protection system to remain stable within a set of defined operating scenarios and procedures. The working principle of a backup protection is divided into two: the backup protection by time gradient principle and the backup protection by duplication. Types of backup protection are relay backup, breaker backup, remote backup, and centrally coordinated backup. Last is the advantages of a backup protection is that it is reliability, assures stability, security of distribution, operation, and other connected components. And for the conclusion of the lesson will be concluded by our leader, Daniel Marco.
Thank you, Vince Nunki. At the end of discussion, we fully understood the significance of system protection in our stations. We help you to identify, to distinguish, and to differentiate the functions of primary and backup protection. Classify the many concepts, forms, and applications of the protection system. We also discuss its advantages in order to keep it, as well as its drawbacks in order to improve and make it better. To sum it up, the primary and backup protection is one of the most important preventive measures to safeguard the main parts of distribution and supply system in case of power surge or unintended high current flow. We are the Group 7, and we thank you all for listening.